And now for two words in math that you probably thought would never be titles of a math topic, box and whiskers. So we are going to make box and whisker plots. The reason they're called box and whisker plots is because they have boxes, and then they call the lines that go away from the boxes whiskers. Hence the name box and whisker plots. What does it do? It shows you your minimum value, your maximum value, your lower quartile, your median, your upper quartile, and if something isn't in, like if you have an outlier, then that maximum value is actually an X, and then the maximum value that isn't an outlier is the end of the whisker. And we can actually make these on our calculator and everything. So usually the question doesn't say draw a box and whisker plot because it's kind of a little bit time consuming. Instead, they give you one and ask you questions about them. So here's a box and whisker plot. Generally speaking, it's to scale. Can you see that the distance between 3 and 6 is 3 times more than the distance between 2 and 3? And it's an ability to give you an idea of how the data is spread out. So 3 is the middle, but it's more spread out to the right of the middle than it is spread out from the left to the left. Okay? What's the upper quartile? That's 6. What's the interquartile range? Well, it goes from 6 to 2. That would be 4. Estimate the number of students who received a mark greater than 6. So these are marks represented by students. Can you see that these are IB marks because they're going from 1 to 7? We have some people getting the lowest mark possible of a 1, some people getting the highest mark possible of a 7. How many students received a mark greater than 6? Well, that would be this section. That's the upper 25%. There was 32 students in total, so we're expecting about 8 students got greater than 6. 50% of students scored between 2 and 6, because that's your interquartile range. Does it make sense that your interquartile range is really your middle 50% of students? Because you've got the upper 25, the lower 25, and the middle 50%. Here, I'll erase this. We can talk about it. The interquartile range is 20, and the overall range is 40. So interquartile range measures from here to here. And the actual range measures from the smallest to the biggest. Does it make sense that your median is 18? Finding the value of A, well, if I know this is 20, then A would have to be 10. If I know the range is 40, then B would have to be 44. Is it hard? No. But is it a bunch of new stuff that you now have to remember? Yes. How good's your memory? Depending on the day, good or bad. So this is what makes it hard, right? Now you have more stuff to remember, and just remember what each of the things mean. So let's put the data in. This would be one you wouldn't necessarily want to rewrite by hand. So we're going to go to our calculator, type these in. So we go stat, edit, clear down to get rid of our data, and just 5.7. And now that we have that in there, we can go stat, calculate, list one, calculate, and it tells us all of our values, the minimum, the maximum, the median, and quartile 1 and quartile 3. Now, we can also make the box and whisker plot with our calculator. How do we do that? We go back to our calculator, we go second y equals, and we turn our stat plot on, and you might have made scatter plots in the past. Have you used the plot option before chemistry? No? So what we're going to do in the type, you can make just dots, you can make a bar graph, we made the histogram here, right? Now we're going to go over to the fourth one. It has a box and whisker plot with dots. There's the box and whisker plot without dots. It doesn't calculate outliers. The box and whisker plot with dots does. So we're going to click on that one. We have list one as our data. We have no frequency. We have no second one that has frequency. So we're going to just keep our frequency at 1. And then when you go to graph, so I'm going to hit graph right now. If you want to see things better, right, so on here, what does it do? Graph, so whisker plot, but the graph isn't necessarily on there. If we hit the zoom button, sometimes what works really nice is number 9, zoom statistics, and then your box and whisker plot appears, and you see that you have a little dot all by itself. Okay? If you draw your box and whisker plot and hit the trace button, it'll jump. Here's quartile 1, 4.2. Here's the minimum, 3.1. The median, quartile 3. It says that 8.4, that's the maximum on the end of the whisker because the maximum right here is actually an outlier. If it wasn't an outlier, it would be connected to the whisker. So we have that 13.3. And earlier I'd said, will we be able to use our calculator to find outliers? This is the one way that you could check if something's an outlier by drawing the box and whisker plot on your calculator. So if you were drawing the box and whisker plot, you would just have to draw the box, label the values. I did them above and below from your calculator. And again, it's all to scale. Oh, was that too fast? Will they ever ask you to use your calculator to draw a box and whisker plot? Probably not. Will they ask you if something's an outlier? Yes. So now you have a tool on your calculator to check it, right? You could also just find the interquartile range and show it. This one we're going to just do quickly. What would you do? You would put this into list 1 with your calculator. You would put this into list 2. If you did that into list 1 and list 2, you could set your statistics up to have list 1, comma, list 2. For those of you that it doesn't appear like this, as soon as you type in 1 var's stats, you have to type in list 1, comma, list 2 after that. For those of you that have a newer version, this appears and you can write the list and the frequency. You hit calculate and you get quartile 1 is 1, median is 2, quartile 3 is 3, and max is 5. This question is asking for those and the interquartile range. Your interquartile range would just be Q3 minus Q1, which would be 2. So again, could you do this on your own with a calculator? Probably. One of the things this unit's going to really test you on is also knowing how to use your calculator, because a lot of these questions are highly calculator dependent. So I'm going to, if you want to see the answers and try this one on your own after, you can re-look at the video. Maybe this is a good one. I'll hide the answer for a second. Unfortunately, I should have pushed enter so it's all on the same page. I'm sorry. Formatting switched it so the data's on one page. You have to write down the values of A, B, C, and D. I'd like you to try that on your own. All right, I'll put up the answers for the first one so you can check how you did. Then you can work on the second one. Or you can call me over if you have questions. All right, quick check on that second one. The data's at the bottom. So write down the values of P and Q. And on here, what I did is I labeled on my bar graphs how many were in each and found out that there was 93 in total. And from the bar, I can see that P would have to be 17 and Q would have to be 11. Now here we're going to have a median class because the data is grouped from 45 to 55, 55 to 65. So where's the middle? Well, if I had 93, 93 plus 1 divided by 2 is 47. The 47th one, where is that going to happen? It's going to happen in between the 75th and 85th somewhere. So then that makes my median class. And if I wanted to find an estimate of the mean, you would take the mid values of each of these. So 50 happens 7 times, 60 happens 14 times, 70 would happen 17 times, and so on. Add those all up, divide by all 93, and to 3 significant figures, I would get 79.1. I'd use an approximation sign because I'm estimating. So the question is, if you had this on your calculator, you can't enter these median class or these classes because they go from 45 to 50. In list 1, you'd write 50, 60, 70, 80, and so on. And then from that, you would get the median and the mode, and the mean could be figured out that way as well.